So
First,
I'm Dave Porter, the engineering manager, as Ramya said, of Polyshot Corporation in West Henrietta, New York. And today's topic is how do we design and build a hot runner system with balanced flow paths that fill all parts equally? How can we use Moldex3D Flow Analysis results to improve our hot runner systems and the performance? And why is this even important for a plastic injection mold? With today's presentation, I will walk us through a Moldex 3D flow analysis case study of a multi-cavity family mold with various size parts. There will be an emphasis on proper hot runner flow balance and how this affects part quality and molding efficiency, resulting in cost savings. Interpretation of the analysis results provided by Moldex 3D will give us clues to what adjustments should be made in a hot runner system to improve its performance and reliability. The final portion of the presentation describes Polyshot advanced hot runner technologies and how they become an advantage when combined with the power of Moldex 3D software. So, first question is, how can we improve plastic manufacturing sustainability? The big answer and the short answer of that is by reducing plastic waste. And a hot runner system can help. A brief hot runner 101 refresher. A hot runner system is a heated manifold and nozzle assembly that delivers the injection machine resin directly into mold part cavities. Cold runners are sometimes reused but often thrown away. With a hot runner system, it eliminates this waste and reduces cycle time and saves money. With that said, hot runners are a sustainable technology. A cold runner, as shown in this illustration, occupies a large percentage of the shot weight, and in some circumstances, it may even exceed the part weight. A hot runner simply leaves a gate vestige on the part with no wasted plastic. Hot runners eliminate waste, decrease mold cycle time, and reduce energy usage.